Okay, so yeah, so today's presentation is about Git as planned. I hesitated a bit between doing a presentation about more like the Git fundamentals and how it actually works under the hood and stuff, but I decided in the end that it was maybe not the most directly useful to people who use Git on a daily basis, but we could do such a presentation in the future if some people are interested. So today's presentation is a bit more about slightly more advanced usages of Git, but without going like completely overboard. Like I don't use like super crazy scripts or anything. I just maybe use like a few more Git commands than some other people use, but nothing crazy. Typically, I guess like Cam could very well give this presentation as well. Like it's not any crazy knowledge. Yeah. So yeah, I mean, I've kind of like I'm like a long time Git user, and I think yeah, it's the command I run the most on my workstation. So yeah, I've been using Git for I don't know how many years, but like for like a super long time. And yeah, so I took the time really to kind of like learn it in depth and understand also how it's working under the hood, which I think also helps whenever there are errors and stuff, because we all know it's not the most user-friendly tool. So sometimes the error messages are completely confusing. And if you don't really know that, oh, that's because under the hood it works in that way, then sometimes it's hard to figure out when things go wrong, what goes wrong. But anyway, so I mean, so Git is complex and it's not super friendly. But then like I think like the basics everybody knows. So I think this is kind of like the basic level of Git knowledge that we expect from people, that they can clone a repository and just edit some stuff and make a commit and push the changes back. So okay, I don't know if anyone here is old enough to have used SVN, except James, who is old enough to have used CVS. But fun memories, I guess. Yeah, but basically, so especially with the rise of GitHub and the fact that we almost always use like a centralized model where there is like a central server holding the data and which we use for synchronizing the collaboration. The way we use Git, if we use like only the super basic commands, is not very different from the kind of like old school centralized version control systems. And that's fine to some extent, but then we're also missing a lot on the good parts and like some improvements that you can get when you use like the command that Git allows, because it's more like decentralized. So this basic stuff, I mean, it's kind of like basic usage of Git with those three commands without really understanding what's happening. It kind of works like until when it doesn't. So like, so the first issue with the merge commits, like where you have like merge in all directions because you just run git pull blindly, and git pull is configured by default to do merge and not rebase. I think we don't have, because most likely people here are like have enough of a clue to set to rebase by default. But it's something which you see like in lots of GitHub repositories, like you will see like merge commits in all directions, which makes the history super hard to read. The second issue or characteristic, let's say, that is here is the fact that like the history is full of like those what I call fixed commits, which is usually like to address review comments or to address like something because you figured out like, okay, it's broken in production. And again, that's not an issue per se, but it kind of like prevents some cool stuff that you can do with Git. And then conflicts, of course, is still scares, I think, many people away, probably rightly. But yeah, I didn't, like I'm not going too deep into on conflicts in this session. Again, if some people feel that they would like to learn more about conflict resolution, we could try to make a session on this. I'm not sure if there is any techniques to help with this. It just feels that once you had enough conflicts in your life, then you kind of like learn how to resolve them. But I don't know if there is any techniques to be more efficient there.
Just tools that are pretty good, like the IDE actually from JetBrains. They are really good at solving conflict on their own already.
Yeah, that's a good point. I think like maybe their good tooling can help. Yeah, I still use like a text editor for most of the resolving I do, but yeah, maybe it's not the most user friendly. Yeah. And so yeah, like as I said earlier, so like those like what I present here as kind of like issues are not necessarily issues. So like if you don't want to have like lots of those fixed commits in your history, just like squash everything in your PR before merging it, and then like all the kind of like dirty commits get squashed into a nice atomic commit with all your feature, and that gets merged, and it's cool. And that's a valid option. I think lots of large organizations also use this model. And for conflicts, I mean, of course, you can just like, mess around by copying your file before the conflict and then after the conflict, and somehow like copy pasting stuff by hand. So I mean, there are like workarounds around those issues. So then you might wonder, okay, like, what's the point? Like, if this kind of works, then why would we bother trying to learn more advanced commands and try to make like a nicer Git history and stuff? If it's just for the beauty of it, it's like super fun, but then maybe it's not everyone's cup of tea. But I think there are some fairly pragmatic and, okay, I'm not sure I would say objective, but at least pragmatic reasons to try to work a bit on making like nice commits and a nice commit history. And the first one, which I think is pretty clear, is for code review. So like the numbers here are actually not invented. This is like right now the Jira integration for Berghain is touching around like 60 files and adding like maybe 6,000 lines of code. I mean, some of it is generated, but whatever, like still it's like files to review. If you want to reuse that as a single commit, or even as a sequence of kind of like fixed commits in GitHub, it's going to be painful because, I mean, yes, you can try to look at 64 files one after another. I don't know if your brain can keep track, at least mine wouldn't. Versus like if you have like more like a staged approach where each commit is kind of like bringing a piece of the puzzle, it kind of helps because it breaks up the review, or it breaks down the review in smaller chunks, which hopefully your brain can more easily process. And then another point is like by having like huge commits or commits which are not like semantically like which are not like super clean, then you prevent yourself from using like some kind of useful tools in the future. So like Git blame, which allows you to know why a line is here in the source code. So like from the line you can go back to the commit, but if the commit is called fix, then you're like, okay, cool, super helpful. Git log -s is a command to search for a given string in all the commits. So for example, like if you're like, okay, like, I have this function, like since when has this function been in the code base? Is it something new, something old? Then you can just grep for the function name in the code and try to find out like, where it was introduced and maybe why. So again, that works much better if you have like commits with good messages and which are not too big. And the same applies to Git Bisect, which allows you to run a binary search on commits by flagging them as good or bad, depending on like if they're working or broken for a specific test. So for example, if you found a bug and you're like, okay, like this bug has been here for, I don't know, like maybe a long time, and you want to figure out where the bug was introduced, then being able to do this binary search is actually quite useful. And then if when you find the culprit commit, the commit is like nice and small and has a nice message, then it also helps a lot to understand why this commit was introduced and what the correct fix would be. And last but not least, if you want to be the first one on GitHub Insight in terms of number of commits, then it helps to make smaller commits. So it's more like a vanity thing. So the thing is, okay, like, cool, we want to have like a Git history where all the commits are nicely shaped and stuff, but it's not really like the way we work now. I mean, like when I tackle a feature, then I'm like, okay, I'll just like put some random crap into random files and try to get things working. And then most likely I'm going to rename the files like 5 times. I'm going to move the functions and split them. And I'm going to rework my Go packages or stuff like this. So it's not like when I start working, I have like a super clear plan and a super clear idea of how I'm going to do things. I'm just going to really poke random stuff around and get stuff working. And I think it's fine. I mean, at this stage, like, yes, I mean, of course, my Git history is going to look like crap, and it's going to look like basically the first code block here. And I'm also going to like be dealing with branches a lot because I'll think, okay, then what if I merge those two modules together? So I'll just like make a branch of my current state and then like continue. And then if I figure out it was a stupid idea, I can revert back to my old branch. So I'm going to use branches as bookmarks kind of a lot and have lots of like throwaway branches, which I'm going to delete afterwards. And so this is kind of like the exploration phase. And it's, I think it's even like for larger tasks unavoidable that it's going to go in all directions and be super messy because that's just how things are. But then it doesn't mean that that's what you have to send for review. I mean, once your code is ready, then like actually reshaping it into nicer commits is not that much work, and that's what we're going to see in the next slides, so that we can somehow like have like a nicer sequence of commits and try to focus on, okay, how do I use the Git history as a tool to help my coworkers review the code and as a tool for myself to in the future diagnose issues. So basically, like, it doesn't matter that the history, like the Git log is like initially what happened chronologically. Okay, that's fine. But then like Git gives you the power to reshape that to like use it as kind of like an organization tool. So yeah, yeah. I mean, there is this cartoon. I don't know if like you people are reading XKCD, but it's basically like you could talk about Git being awesome because this and that reason, but then if nobody knows how to use it, it's not super useful. And it's like, yeah, there is always kind of like also like a tooltip text on XKCD, like as an extra joke on the comics. And for this one, I think it was something like, okay, like, you know, if everything else fails, so it's like this phone number of this guy you can call to get some Git help. So yeah, as I said at the beginning of this talk, it kind of helps to understand a bit in depth, like what is a commit and, you know, like how does Git work? Yeah, so again, we're not going there today because I think it would be a bit too much. I found like there was a recent blog post on the GitHub blog about this, which I found not too bad and not too technical. And then if you're really into it, like the second source, like in the Git book, is really good, but it's more content, so you need to plan a bit more time if you really want to understand. I mean, also you need to decide if it's important to you or not. But the first, I mean, the blog post is kind of like a quick read, maybe 10 minutes. It already gives an idea about like a bit some fundamentals of Git. Also, like slightly related is a couple of tools which at least I personally find make life easier when dealing with Git. So there is one tiny thing called Git PS, which is officially in the Git source tree. So it's not like a random script from some random dude that just like changes your shell prompt so that you can see like where you are. So for example, here I can see I'm on the branch master and I'm like in the process of doing some interactive rebase and I'm on commit 1 out of 2. So yeah, you always have the branch name and it kind of like puts some, I think, like useful information to kind of know where you are. And it's quite easy to set up. It's just like one line in your bash RC or ZSH RC. And then the two other configuration parameter we are going to see why those are useful in the other slides. But it should just like make it slightly less annoying when you're rebasing a lot and you maybe have some uncommitted files and stuff. Yeah, maybe to go back to the tooling a bit. So yeah, as James mentioned, I guess yeah, like the conflict resolver from IntelliJ is quite good. I haven't tried the one from VS Code. I've seen James use SourceTree also, which also seemed to be quite nice. And I guess it's free. So I mean, if it
yeah,
helps,
it's from Atlassian. It's very good commit client. I don't use it for resolving conflict. I think it only opens it in an external thing. But for selecting basically the file and reviewing the chunk and easily add some lines, add some chunk to the commit and all this, I find it really good. So yeah, if someone wants like a good Git UI, I can definitely recommend SourceTree. I'm using it for like, I don't know, 5-6 years easily. I was using it a lot in 2014. So yeah, good tool.
Yeah, no, it's yeah, good information. Because again, yeah, I'm doing really all my stuff in the terminal, so I'm not a very good advice for those things. But okay, yeah. So to go back to like our point of okay, like how do we make nicer commits? Like there is like a first technique which I use quite regularly, and so as I said before, like when I write the code at the beginning, I just like do random commits and like with lots of like stupid commit titles and I try to get to a state where things are working. Now, so that's kind of like the first point, and then once I'm done, I'm like, okay, like now I have a state of my code which seems to be what it's supposed to do. And now I'm going to start the stage of like, okay, I'm going to reshape my commits to make it easier to review and like to make like nicer commits. So the first thing I do is I create a backup of the branch where I am because I don't want to lose the files that I spent maybe days putting together. So I just create a new branch with -back or whatever you want to call it first. So I create a backup branch. Oops. And then I just do like this.
You create it from the branch where you are, or you create it from master? Okay.
No. So from the branch, yeah. Okay. So here, Git branch. If I don't specify, like if I just specify a name here, it creates it from where you are right now. So that's it's a good question. That's assuming I'm right now on the topmost commit of my working code. So I just create a branch from there, and then I reset to like origin master, for example, which would be like the latest stage of like the latest master from upstream. So after I ran this, basically Git forgot all the commits I just did, but it only did so in the Git part. So it didn't touch my files. That's what we call like a soft reset. So if we do a session on more like in-depth Git command, we can discuss like what is a reset, what is the index and stuff. But for now, like all we need to know is like this is not touching any files. It's only telling Git, okay, consider that you're right now on top of origin master, and that any differences that you see in the files around you are like new things basically. So after I run this git resets, if I run git status or git diff, it's going to show me all the code that I have added on top of origin master basically. And so starting from there, it's kind of like, okay, it's a bit like if I had been doing all this work without doing a single commit, which would have been quite risky. But no, I know it's not risky because I backed up my branch earlier. And so now that Git considers all my files are as changed, I can start to add stuff and to shape my commits. So the way I like to add stuff is to really go through each file and through each what's called like a hunk in Git terms, which means like each change inside the file. So really like each block of change lines. So I use git add -p for that. So -p means -patch. It means it's going to show me each single patch in each file and ask me, hey, do you want to add it or do you want to like leave it aside for now? Yeah, so that's also something that source tree can do quite nicely. So you can list all the changed files and in each file all the changed lines and decide whether you want to include them in the commit or not. And so starting from there, I'm just going to like git add all the stuff I want to add in my first commit and then git commit to do my first commit and then start again. And as long as I have some uncommitted changes, I just like stack my commits one after the other. And I hope that at the end, I have like a commit log which kind of looks reasonable, and that I don't have any uncommitted changes anymore or any untracked files. So this is kind of like doing the work and then doing all the commits afterwards. It works for me. And then if I ever mess up something, like if I run like a wrong git command or whatever, I know that I can always go back to my backup branch and find my work back. One thing which is really helpful for me, at least, is also the fact that I just have like a fresh look at all the files I changed and all the things I changed in each file. And it's kind of like a self-code review. And I mean, of course, it takes a bit of time, but at least for me, I find it super useful because then it makes me reflect on the design choices I've made, on the names I've picked. Maybe I find some typos, maybe I find like some error messages which could be better. And so it's kind of like a pre-self-review of my code. So like, even if it wasn't for Git itself, like I think I find it at least personally quite useful to go through all the changes I've made and to have like a last look before sending them for review. So I mean, of course, it's only up. Sorry, yes.
No, please finish your sentence.
No, I was saying like I guess this is mostly relevant for larger features. Now, I mean, if it's like a small bug fix, of course, you're not going to go through trouble. Like you're just going to like make a single commit and then maybe you just amend the commit to change the name or something.
So I have one question. The reason I'm sometimes worried about doing that is basically I don't know a way to validate that each commit is working well. I could see easily that, I don't know, I select a hunk where I change the function definition and I miss one line in another file where actually I was also changing the function, the call to the function. And then you could have basically a commit that doesn't compile and you don't even see it. And also maybe the tests that you push with that commit actually are not updated just for that, and it will break and basically I always try to be careful that we can roll back to any single commit, or that you can check out any single commit and the code will work, including the test. And that's the issue I have with this technique, is that I don't know how to guarantee that. Is there a way?
Yeah, no, it's a good point. Yeah, I mean, so yeah, like, I guess like technique 2, which we're going to look at afterwards, helps a bit. But yeah, basically like what I do then is I go through each commit also and check that it compiles, it works. So it's like it's kind of like a two-step thing, but it's a valid concern.
So you do first the technique 1 and then you validate with the technique 2. Okay.
Yeah. And so yeah, but it's a good transition. So yeah, going forward to like technique 2 is like using
Sorry, can I also
yes,
quickly? Sorry. I have kind of like a similar issue when I do something like this. So first of all, thank you. This is super helpful. But for me, or maybe it's a front-end issue. We often have issues that are not so easy to isolate from one another. Let's say in the same function block, you do a renaming and you also add a feature, but you wouldn't want those to be in the same commit. But eventually, because you take your final version of all the changes, they kind of depend on each other.
Yeah. And I think, I mean, at some point, I think this issue is somehow like impossible to solve. I mean, okay, it is possible. So either you manage to do like reasonable enough commits from the beginning, so that your how to say, like chronological and your correct organization of the commits kind of match. So then you can do that because you did the rename first and then you actually made that a separate commit. If you I mean, it's true that if you haven't done it from the beginning, you can try to do it afterwards and to kind of like split, but yeah, maybe it's going to be painful. I don't know if there is a magic solution to that one. And yeah, at some point, I mean, okay, I mentioned it a bit later in the presentation, but I think we also need to be pragmatic. Like sometimes, yeah, I have these issues and I'm like, okay, I'll just bundle the rename with it because splitting it would be too hard. So it's always a cursor somehow between, okay, I want to make nice commits, but I also don't want to spend half a day just like in Git. So yeah, I don't know if there is like a big solution, but yeah, so like going with the interactive rebase maybe can help sometimes. So let's see. So the interactive rebase is it allows you to somehow like go on an existing sequence of commits and either reorder them or delete some commits or change some of the commits. So it's powerful. It's also risky because you can mess up and then lose some code by accident or something. So we'll also see afterwards how to somehow like go back if you figure out you've broken something. The interactive rebase I use it also while developing if my commits already makes sense to some extent, or I use it also always when addressing code review comments. So that's a way to somehow like avoid those fixed commits where you have like 10 fixed commits on top of the work you've done. So scenario is the following. Yeah, you've sent like 3 commits for review. And then like somebody tells you that there is an issue in like something that you've done in commit 2. And what you want to avoid doing is just like putting a 4th commit on top, which is just called fix commit 2 or something. So a way to do this is like with interactive rebase. So you have to choose where you want to start the rebase. So you just like say git rebase -i and you give the commit hash of where you want to start the rebase, and it's going to start after the commit. So in this example, we just pick the hash of commit 1. And then it opens the text editor. Maybe there are some GUIs where you can also like do the same, but yeah, so basically the text editor has like 1 line per action, which is going to be carried. And so by default, the rebase is just going to pick like all the children commit of the base that you chose. So if you chose commit 1 as a base, then the default action is what you would expect, like which is like picking commit 2 and then picking commit 3, which would basically be like doing nothing. So yeah, the syntax is like first the action and then the commit hash, and then the commit title is here as a help, but it doesn't really matter. Like it doesn't care what you put in there. So here what we want to do is like, okay, like we'd like to do some changes in commit 2. And this is going to loop a bit to like James and Hannah's question. So one way to do it would be to make like a force commits with like the fixes, and then to try to somehow like merge that force commits inside commit 2. But then you have the issue that maybe your force commit somehow like depends on stuff that was in commit 3, and then when you're going to try to put commit 4 below commit 3, then you're going to get some conflicts and stuff. So it's not super fun. So usually the easiest is to, like in the list of commands, ask Git Rebase to stop when cherry picking commit 2, so that we have a chance to implement the changes which were requested during the code review. And then because when we stop at this stage, the commit 3 hasn't been picked yet, then we're sure that we're not going to accidentally mess up with some code that is coming in commit 3 later. So, and like to go back to the renaming example, for example, for the front end, I guess what you could do is try to rebase on the commit before your feature, and then do the rebase and try to cherry pick your commit and on top, and hope that you don't get like a shitload of conflicts. And I mean, if it works, it works. And if you get like a ton of conflicts and you figure out, okay, like this is not worth it, then you just put the rename in the same commit and end of the story. So yeah, like in this example, yeah, then like we ask to edit the commit 2, that's with the E here. And so like Git is going to stop after cherry picking the commit 2. And then we can just like edit the files and implement the changes that we wanted to implement. And then we just commit them, amending the existing commit 2. So, I mean, I always use git add-p because, yeah, then I'm sure of what I commit. But I mean, you just like stage them the way you prefer. And then we just do like git commit amend, which means like the changes we just did are going to be merged back into the commit 2. And then we resume the rebasing, which means like Git is going to pick the commit 3 on top of our new revision, so to say, of the commit 2. So then like we have the changes that we wanted to have in that we wanted in the commit 2, who are now like in the history. Yeah, and yeah, like as a kind of like alternative way. So yeah, if we're sure that we can do the fix up and that it's not going to interact with commit 3, we can also just use this git commit -- fix up, which is kind of like a shortcut. So you can commit the stuff and then like ask to, like you can tell Git, okay, this is just like a fix up commit for that other specific commit. And then when you do the interactive rebase, assuming you've set auto squash to true, as we've seen earlier, Git is going to automatically put it in the right place and automatically pick up the right action. So that I find quite useful if it's like something super small that you know won't cause any conflicts. Like for example, you're fixing like a typo in the API docs or whatever. It's super quick. Like I just go through the PR and I see the comments and like I could like almost have like a browser on the left side and the terminal on the right side and just do like tiny fix up commits and just run like Git Rebase interactive to merge those fix up commits as I go.
You can also You can also do fix up within the interactive like console. I think that's a little bit easier. So like when you when you do git rebase I, it'll show you like all the commits and what you want to do with them, and then you can just say instead of pick you say F, and then it squashes those two.
Yeah.
That way you don't need to keep in mind the commit hash with that.
Okay. You can also edit the commit, right? During the rebase, you can instead of pick, you can say edit, and then you can also make the change directly inside there, which then have to run the test on the specific commit and make sure you didn't break them. Basically, that's what I do sometimes.
Yeah. So the fix up stuff here is really just like tiny changes, which I like that I usually use it where I know it's not going to break the test and stuff. If not, I agree, it's maybe easier to switch to use like the E action. So like actions, you can do pick, you can do edits, you can do fix up, you can do squash, you can do R for rename, and probably some other ones which I forgot, but it's all in the help. Like when your editor opens with the, so that you can kind of like program your interactive rebase, there is like a help section at the bottom which tells you which commands are available. Yup. Yeah, and so that's kind of like a way to like fairly cheaply amend some existing commits without like losing hours doing it. So yeah, but sometimes you realize you've just messed up because I mean it's especially if it's a complex change, it's easy to sometimes get lost in the interactive rebase. Also, like for those, at least like so the Git prompt stuff I mentioned earlier, like this thing, like where it shows you in your prompt where you are. At least for me, it really helps not like getting lost. But I mean, sometimes, okay, you're just going to like merge stuff into the wrong commit or like, touch the wrong file or whatever. And then you're going to say, like, oh, too bad, I messed up thing and I don't have a backup. So, I mean, okay, if you had a backup before, then, all good. You can, of course, always go back to that branch. And if you did not have a backup, well, I mean, Git keeps a log of what you've been doing, and which is called like the ref log. And so like by doing Git ref log, you kind of see where you're ahead. So what Git calls ahead. So it means like where you're currently at, basically. So where your head has been for the past calls. So here there is only 6 lines in this example, but I think the default ref log is, I don't know how many lines, but like clearly long enough that you always have enough ref log to go back, to rewind back to whichever state was not broken, hopefully. And so here, taking this example, like explaining a bit more, like if we take back the example of like technique 2, so we had done this commit 3, so that's like this line in the ref log, and then we did this fix up commit, and then we started the interactive rebase. Commit 2 fix up was merged in commit 2, and then like it went back to the branch. So like I think it's fairly easy-ish to understand the ref log, and to find like, okay, if I want to rewind to a specific state, where you want to rewind. So the first column is always like the commit hash. So you can always, for example, create a new branch based on that hash and see, okay, like, was this a state where the files look like I expect? And if yes, then you can always like use that to go back and find back the stuff you lost. And every time you do like a Git operation, it's appending to the ref log. Yeah. So basically at that stage, like the interactive rebase is basically just like the main tool that you need whenever you want to have like a cleaner history. And I mean, of course, at the beginning, you're going to make mistakes, and then like with practice, I feel like, I don't know, like nowadays it's, I think, fairly rare that I mess things up by doing like an interactive rebase. And yeah, if it happens, I just use a ref log to somehow like go back to where I wanted to. And yeah, so as discussed a bit earlier, like, okay, no, it's all cool. No, we had like beautiful commits, but what do we do with them? So yeah, like this git log -s, for example, is something I really use on a regular basis to like, for example, like find where a function was added, or like, where an error message was added, or these kind of things. And yeah, like same for Git. I mean, Git blame I use less often. Git bisect, to be honest, I use fairly rarely, but when I do, it's really nice. So yeah, it's all kind of like nice little perks that you get from having smaller commits.
So the git log s, does it shows you all the commits that touch this specific? That basically it's a git search and it shows only the commit names, right? But it's not only the one we introduced it's actually going to show you all the one that modified this function.
Right? Yeah, it's going to look in the diff of each commit basically and look for the specific string in there.
Okay, and what is Git Bisect exactly? I don't understand how
Bisect, so it's a binary search. So if we figure out today, like we have a bug in production, and we knew that 2 months ago it used to be working somehow. So we can go back to a commit from 2 months ago and run it and figure out, okay, was it actually working? And if yes, like now we want to figure out, okay, like where did we break things? Like where did things go wrong? So you can do git bisect starts, and then like you put head as the head is like the bad commit, so it's where you are currently, assuming you're on the latest commit. And then like as a second argument, you pass the commit ID of like that old commit that you figured out was working. And once you do that, then Git is basically going to drive a binary search for you. So like it knows that there is an old commit which was working. It knows that there is a new commit which is not working. So it's going to pick a commit in the middle and ask you, okay, like, is this commit working? And then you just answer yes or no. And then if it's working, it's like, okay, then it's going to take like commit between this commit in the middle and the end. And like by slicing by like the interval in 2 over and over, it ends up finding the commit which broke stuff. And if your command to figure out if things are working or not, like if it's actually a command, so for example, imagine you just wrote like a small program which returns 0 if it works and 1 if it doesn't work, then you can even give that command to git bisect and it's going to drive like the whole thing automatically. So if you have a command to, yeah,
that's
so
cool.
it's quite cool.
Could you add like, for example, a test? You could get like, you could add like a Go test that is not part of the not part of the index, and it will stay there, and then you just run this test. Okay.
Yeah, exactly.
Have you used that already?
I use it always like pretty rarely, to be honest. I mean, so this is one of the features which is really awesome, and it's kind of like a good marketing feature. In real life, I've used it like, I mean, if I use it like not even once a month, I think. I would say like maybe once every 2 months or something.
I think for a team of our size, it's really easy to find a bug. But if you have a huge team with lots of commits, it's harder. One time I used it to find a performance regression where it's not clear. Like if it's a bug, you know where the bug is probably. It's really obvious. But I was doing performance on Android, and like it could have been anything. So that was one time that I used it. But I think for our team, for finding a bug, it's probably pretty easy to go without it.
So it was the same? You had like a performance test, and you were like giving it and trying all the commits until you find the big difference.
Yeah, a profile test.
Profile test, okay.
Yeah,
right.
I mean,
and can you give also like a so then basically your command is the exit code, I guess, that tells you if it was right or wrong, and then you put like a, in case of performance, you put a threshold, and if it was too slow, it return like a positive exit code, and then it stops the Git Bisect on that specific commit.
I don't think I used I don't think I gave Git a hook to run.
Okay.
I think I just did it myself. Yeah.
Okay.
Yeah, even if you do it yourself, I mean, in the end, because it's a binary search, it's going to be logarithmic in number of commits. After like 10 steps, basically you have like searched among like 1,000 commits. So it's, even if you do it manually, of course it's painful, but it's never painful for a super long time.
Cool.
Yeah, and yeah, I think another context like where Git Bisect can be useful is also in third-party dependencies. Like basically anywhere, like basically what Cameron was saying. In our context, okay, we know the code base well enough that it's maybe not that useful. But in a third-party dependency where you don't know the code, it's also quite useful to figure out, okay, like, where did something break? Like for example, we upgrade like whichever dependency we're using, we figure out it broke Berghain, and we want to figure out, okay, like which version of the dependency broke it. Then Git Bisect can also be quite useful there. Especially in our case where like we are not super regular with third-party dependency upgrades now. So it might be we upgrade from version 1 to version 25. And then like it's going to be hard to figure out what broke. Yep. Yeah. And so yeah, so like like some nice, I think, profits to gain from this on top of the code review, which I think is also much nicer to do when you have like nicer commits. Yeah, it's not all rosy. So yeah, like GitHub is really comically bad at handling history, like when you rewrite the history. I guess it's not how they work internally. I don't know. I cannot explain like how bad it is, but it's really bad. So it will like, it cannot easily show the differences between two push that you've been doing. So if I push 3 commits and then I get some comments and I like amend those 3 commits and push them again, then on the first push, I think GitHub is going to kind of be able to show the differences. But then if I push again, it's going to lose the old commits. So it's like, sometimes it makes it harder than it should be to figure out what has changed between 2 push from the person asking for a review. And that's quite unfortunate. And also it's not really good at encouraging reviews commit by commit. I mean, it's not too bad. Nowadays you can switch between commits with the N and P keyboard shortcuts. So it's okay-ish, but yeah, it's not great. So there are other tools like Gerrit, which is a tool which is used. I mean, it's a fork of, I think, what Google uses internally. I'm not sure if it's still the case. I guess Cam can confirm. For code review, like it's used for Android, it's used for Go, it's used for many large software projects. And Gerrit, for example, is able to like track this much better and also really encourages review commit by commit. So like if you have a PR with 5 commits and the first 3 are good and the 2 last ones need some work, then you can already merge the 3 first ones and you don't have to think about them anymore. And you can just like do the work that you have on the 2 remaining ones. So yeah, at least like in the time I've used it, I think it made it much easier to, like it reduced the pain when doing pull requests, because you would just like merge as much stuff as you could quickly and just like focus on what was actually remaining.
And how big is the effort to set this up?
the thing is like GitHub is not only GitHub now, there is also GitHub Actions and there is to login and stuff. Just like
it's instead of GitHub. It's not on the side of GitHub.
On the side, but I mean, yeah, you're right. GitHub Actions could still be triggered by a regular GitHub PR.
It's basically just the review process that could be done in Gerrit, right?
Yes. Yeah. And you would need to give Gerrit the rights to merge commits directly without going through PR. Because when the commits are approved in Gerrit, you can merge them. I don't know. I mean, it might be it's like 2 hours. It might be it's a week because there is some stuff I haven't forecasted. Okay. So it's like something I'll do like on a weekend or during a train ride or something when I'm bored one day. But yeah, so far I haven't really looked into it, and I know it's a tool which also like not everybody loves. So like I really like how it works, but I'm sure some people would find it like shit compared to GitHub. Mm-hmm. So if it's something on the side which is not mandatory, maybe it doesn't matter. But yeah, let's see. Yeah, and yeah, as we said earlier, I mean, of course, like the idea of this talk is not to make everyone like spend 3 hours in Git for each 1 hour writing code, because if not, we are not really we're not really getting much from this. So yeah, like in the end, we're not getting paid to do Git commits now. So I guess yeah, we should always try to stay pragmatic with this. At some point, okay, sometimes like you messed up and there is a big commit to review. Well, too bad, but it's not the end of the world either. So, yup. Yeah. So for the basics, that's pretty much all I had. I have like 2 slightly more advanced examples. I mean, like practical, but a bit more like a bit more advanced examples. But this is maybe only of interest for like curiosity or something. I mean, it's like stuff I used on a regular basis also. So, for example, like when after doing my commits, I figured out, okay, like this particular function is in a commit a bit too late. Actually, like a commit before already needs that function. So I want to migrate, for example, a function from a commit to an earlier commit. So yeah, I don't know if we want to go through them together. I think it's also fine to somehow have this as a recipe, but that you only look at when you need it.
I mean, if someone doesn't want to look at it, anyone can feel free to leave the meeting if they want to. And I would suggest that you just keep going.
Yeah, I only have 2 of them anyway. I have like only this one and the other way around. Like when I have a function which I want to move to a later commit. But yeah, it's more like, I guess if everybody somehow like understands how this works, and we're good. If some people have questions on how this works or why this works, we can discuss this. But else in terms of raw content, this is pretty much all I have.
Cool. I mean, thanks a lot. For me, what I can say is like, I mean, I didn't know all these. I mean, you already showed me quite a few of these commands, and to be honest, it already changed my life quite a lot. But I think the biggest improvement, and I think we talked about it a few times in the engineering meeting, was really this concept of pushing small commits that make sense, because reviewing your code has always been very easy, and I can say from experience it's not always been like this before. She's never been like this before, and I think that's for me like the biggest changes. Like I would say the best Git user as in terms of colleagues are not the one who knows all the commands. They are the one who make a lot of tiny changes that make sense. And basically, each time I review a commit, I looked at what it does. It does, I don't know, I'm changing this function because of that. When I look at just a few lines of code, everything makes sense, and I go to the next one. And basically, the context in my brain is only always like a tiny small context, so I can really think about how these changes make sense. When I've been reviewing and I've been doing a lot of big commits that have a lot of changes, and then it's super hard to really review like with a deep understanding. Usually I end reviewing like, is the code ugly, or is there eventually a loop that doesn't make sense, or stuff like this, or is there an error that is not checked, but rarely like, does it really make sense business-wise or algorithmically wise, whatever word I just invented. So for me, like the biggest recommendation I can say for people who are not doing it today is really trying to make a lot of small tiny commits that make sense with a good commit message that change the life of your colleague, and they will love you for that.
Yeah, one thing that I think was like I guess one cost is that it's more work to go through and do it, but I think it's just part of the work. So what happens when you have one big commit is usually you say what the commit does, like what the commit achieves, like fixes X or enables Y, but it's not clear what is being done to achieve that. And sometimes one of those subparts, sub-decisions might be wrong or questionable, but it's not clear from the big commit. So I think the work is usually worth it because it's actually doing the work of breaking one thing down into small decisions. And those decisions can be debated, but if it's a huge change, then it's like fixes X, and fixes X is great. Like we love that it fixes X, but we're not sure what we did to fix X without the breakdown.
Yeah, totally. And also, I mean, two more things. I think, well, and Adrien mentioned it, like if you go through your code, try to fix a bit your commit, it also forces you to really go through your code more than sometimes we do. And I know that's why I do all this commit step by step, and I do sometimes figure out some things that are a bit wonky by doing that. And the second reason I would re-insist on what I just said is basically, if you just throw one big commit because it's easier, you just throw your work on your colleagues, which can be first multiple person. So you're going to waste the time on multiple person. And also in the end, we are still asking a favor to our colleagues to review our code. We should, and as always, when you ask a favor to someone, you should always do it as nicely as possible. So I think in terms of like, you know, being kind, respectful, and responsible, it's on the duty of the person who write the code to try to make it as easy as possible to the person who review it later. So I think it is important to try to add the context that is necessary, the right comments in the PR and all those things, and tiny commits helps a lot from my experience.
And then yeah, like so yeah, I understand that like it's also either I mean, as we said, okay, like it's more work, and yeah, it can be intimidating because yeah, like the Git UI is what it is. But clearly, like I mean, I'm happy to be like the Git person that, you know, like whenever people have questions, just ask. I mean, I guess like ask not me, like asking the engineering channel, but I'm happy to to support and like take some time and do like a quick Zoom call or whatever, to somehow like bring the Git level of people who want to improve it up. Yeah, I think it's a worthwhile improvements. But I also understand why it's not everyone doing it, because yes, it is complex, and yes, the error messages are shit, and yeah.